Today we're going to be talking about parallel transversal angles. So we know that we have two parallel lines, they're never going to meet. And we can show that these are parallel by putting little arrows here on the side. So this indicates that these lines are parallel. And we know that a transversal is the line that cuts through a parallel line. But we can see that this creates angles. So we have one angle here, here, 3, 4, 5, 6, 7, and 8 angles. Also, just to recap, there's some things that you already know. An adjacent angle, or sorry, a set of adjacent angles are angles that are touching. So, for example, you could see that 1 and 2 are touching. You also know that complementary angles together equal 90%. You know that supplementary angles together equal 180. Degrees, and you know that vertically opposite are congruent. And the congruent sign looks like this. Okay, so now, remembering all of this, there are other properties that are shared by angles that have similar or congruencies based on the fact that they are in certain places related to the parallel lines and the transversal. The first type is alternate interior angles. And we use the Z or Z to help us find these. So what does that mean? If we have our parallel lines and our transversal, and remember that the transversal can come at a different angle, but just this one is easier to see. Here we have angle 3, and here we have angle 6 based on the above diagram, and you see the Z here. So what this means is angle 3 is actually congruent to angle 6. Whatever angle 3 is in terms of degrees, angle 6 will be the same. But you can also see the same property in a backwards Z or Z. So here we have angle 4, and here we have angle 5, and this actually forms a backwards Z or Z, which means that these have the same properties. Angle 4 is congruent to angle 5. So whatever degrees angle 4 is in measure, angle 5 is the same. So, for example, if we had a situation where we knew that these were parallel lines and this was a transversal and this was 40 degrees, and we were looking for angle M, then we could say, here's the Z, which means that angle M, this is a step, remember, angle M is congruent to 40 degrees. And what would our justification be? Our justification would be alternate, and you can abbreviate here, interior angles. The second type would be alternate exterior angles. And this isn't as clear, but you kind of use pointing V's to help you. So if we have our parallel lines and our transversal, if we had this as angle 1 and this as angle 8, we could see that we have the angles are exterior, so outside of the parallel lines, but they're also alternating. So one is on this side of the transversal and one is on this side of the transversal. So you can see that if you put these together here, they would be sharing the same vertex, but they're on alternate, so outside sides to one another. But as we saw in the other example, you can also have the same situation on the opposite side of the transversal. So here we had angle 2 and here we had angle 7. In this case, they are both exterior, outside the parallel lines, and on opposite sides. So what does this mean? It means that angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. If we did an example, if you knew that this was 50 degrees and you were looking for the measure of angle A, under your steps, you would say angle A is congruent to 50 degrees, and your justification would be alternate exterior angles. Why? Because you have a situation with your pointing V's. The third type is called corresponding angles. And when we're looking for corresponding angles, we think of an F. So if we have our parallel lines, our transversal, and this is angle 4, and this is angle 8, together it creates an F. The reason it's called corresponding is because they're in similar positions. This angle 4 is underneath the parallel and between the parallel and transversal, and angle 8 is also underneath. So what does this mean? It means that angle 4 is congruent to angle 8. But there are many different types of F's that we can think about. We can also think of the instance of a backwards F. So a backwards F would be here, which would then mean that angles 3 and 7 should also be congruent. But that's not all. We also have the case of an upside down F. So in an upside down F, we could say that angles 6 and 2 are congruent. But there's also the case of an upside down backwards F, which would be here, which would mean that angles 5 and 1 are also congruent. So for example, if we had a situation where you were looking for angle Q, but you knew that angle, this angle here was 48 degrees, then you could say, steps, angle Q is congruent to 48 degrees, and your justification would be corresponding angles. Why? Because of the F. They're both on the same side of the transversal, but they're both above the areas. It's a upside down F. There's one more important grouping of parallel transversal angles, but they're a little different. These are called co-interior angles. And when we're thinking of co-interior angles, we look for C, but it's important to note that these are not congruent angles. So everything so far has been congruent angles. In this case, the angles have a sum of 180 degrees. So altogether, they have 180 degrees. Now, where do we find this? If we have our transversal and our parallel lines, the C is inside the parallel lines. So in this case, it'd be angles 4 and 6. So the measure of angle 4 plus the measure of angle 6 together will equal 180 degrees. But like all the other ones we saw, you can also have the same thing on the other side. So a backward C, which means that angle 3 and angle 5 together, you add the values up and you should get 180 degrees. And this will be really helpful if we're looking for other angles to have this kind of information. So then if we do an example, if I had my parallel lines and my transversal, and I knew that this was 150 degrees, and remember, things aren't always drawn to scale, I could say that in my steps, and I was looking for B, I could say that angle B plus 150 degrees equals 180 degrees. My justification for this would be co-interior angles, and then I could just do my math. Angle B would be 180 degrees minus 150 degrees. Subtract from both sides. This will cancel this out, so I have a subtraction on this side. So angle B, therefore, would be 30 degrees. There you go. Today we're going to talk about parallel transversal angles. So we know from what you've already seen that two lines can be parallel, and we show this by putting these little arrows on this. If there's an arrow